Rivers are incredibly important. People use them for transportation and irrigation. They provide habitat for all sorts of animals and plants. They are a place where life flourishes. You probably already appreciate that rivers are an important source of water for plants and animals. But did you know that rivers have an incredible effect on our geology and geography as well? You see, rivers are sediment movers. As water flows over rocks and dirt, it picks up small pieces of clay and sand. The faster the river is flowing, the more sediment it can hold. But when it eventually makes it to a lake or an ocean, the water slows down and the sediment drops, forming a fan-shaped piece of land and marsh called a river delta. But rivers don't just move sediments. The river itself will naturally meander, carving out not just a channel for itself, but forming a floodplain, shaping the entire region around it. I'm Science Mom.
And I'm Math Dad.
Today we're exploring some of the largest and most important rivers in the world. Hello, and welcome to Amanda, Nathan, and Margaret, to Eleanor and Isaac watching live. Hi, Science Mom Krista and Science Mom Amber. Shout out to Science Mom Jamie and Pikachu, Millie VK, and many others. Special welcome to you if you're watching the replay. To start off with, I have a quick little story. I grew up next to a river in Utah, and my grandparents were from Oregon. And one day when my grandpa was visiting, he said, "You call that a river, but in Oregon, we'd say it's a crick."
A crick?
A crick. Or creek, you could say, but in his, the way he said creek was crick.
Crick.
So what is the difference between a stream or a creek or a river or a rivulet?
Well, I would say it's the size, right? So if it's big, it's a river. If it's tiny, it's a creek. And what were the other ones?
There are a lot of different names for a river, but really, scientifically, there is not a difference between a stream or a river. A river or a stream is water flowing downhill on the surface of the land. Anytime you have water flowing downhill on the surface of the land, you could call that a river. But traditionally, we tend to call larger bodies of water rivers and smaller ones creeks.
On the farm, we had a ditch for irrigation. So we'd open up the gates and the water would come down it. Was that a river?
Well, that's not a natural source of flowing water.
Okay.
So yeah, ditches and canals and things, those are man-made, right? But if you live somewhere really wet like Oregon, where most of the big rivers are really big, then a river that would seem big to someone living in the desert is not going to seem big to you. So you can see why defining things by size is a little bit problematic.
That's right. We're just glad to have any water we can get in the desert.
But whether your river or stream is large or small, there are certain things it does as it moves that are incredibly powerful in shaping the land. So let's go to the notes. We're going to be in page 94, and we're going to talk just a little bit about some of the parts of a river and how it works. Now, the first thing to point out is that most rivers are going to have tributaries. So if you are filling in the notes, if you haven't already, you can write in tributaries here. And my handwriting's sloppy because I'm kind of writing along the side there. Yeah. Math Dad's going to fix it for me.
No points for Science Mom today.
And defining what part of this whole basin of water running together is the river and which ones are tributaries, it can be a bit of a matter of opinion. Usually we go with the highest source is going to be the headwaters of the river, and then smaller channels that join it we call tributaries.
So when two rivers meet, the name doesn't grow bigger, right?
It all depends. Sometimes the name can change when two rivers meet. Sometimes whatever river is the biggest, the name will carry. It all depends. But the source of the river, that's where the river starts. And usually the source of the river is going to be a spring, or it's going to be up high elevation, high in the mountains.
Do rivers have just one source?
It all depends.
Oh.
It all depends. But usually people like to find the highest tributary and they'll call that the source of the river.
Gotcha.
Then as the river is coming through, we're traveling down, it's getting bigger and bigger, it can start to bend and curve or meander. And as it's bending and curving and meandering, some pretty cool things can happen because the water is flowing at a certain rate, but then as it curves, the water will flow faster on the outside of the curve, and that will make the erosion bigger. And over time, it will carve out further and further, and then eventually this part where it's carving out further, they'll touch and a new channel will form and you can get an oxbow lake.
Ooh, that's kind of cool. So the reason that the water would go faster on the outside is because it has to travel further to keep the flow going.
Yep.
And that's always going to happen. So it's going to, this pattern will happen with almost any river that's going to meander back and forth.
Yes, any river that is in a channel where there is room for it to move. Once a river gets into a steep canyon, then it just doesn't have as much room to move, and then it will just stay on that course.
Sure.
But if it has a floodplain, it is going to change where it is. It will meander back and forth, and then when it floods, it might pick out an entirely new course. So we have Oxbow Lake right here. We have meander. And then down at the bottom, once the river reaches the lake or the ocean, wherever it is flowing to, then we have a river delta. And that's when it's going to drop all the little tiny pieces of clay and silt that it was carrying.
Okay, that's pretty cool. So the beginning of the river is the source.
And the end of the river, if we're hitting into the ocean or the lake, often it will form a delta, but sometimes we call the end of the river a mouth. So the mouth of the river is that beginning part of the river if you're coming in from the ocean.
Okay.
So those are some terms that we need to know. And now if we look at a map of a river system, this is the Mississippi River, one of the biggest rivers in North America.
That is enormous.
Which one of these would you call the Mississippi?
Oh.
So take a guess, Math Dad. And I will tell you, this map is a little bit misleading because the line thicknesses are all the same. So this big part of the Mississippi down here, which is enormous, looks
a mile wide, right?
Yeah, it looks about the same as, this tributary up here, which is a lot smaller.
Okay, so that makes sense. The thickness of the lines on this particular map is not particularly meaningful. I guess on most maps, it wouldn't mean too much. But okay, so where is the Mississippi? Well, my guess is it goes along Mississippi here. So I'm going to come up along Mississippi.
And Adley says that it looks a little bit like a leaf. I like that connection because the veins that you have in a leaf do look somewhat similar to the veins you get in a river. No. And now you've got to choose where to go.
So I know the Missouri River will meet the Mississippi River, but where do they meet? I guess I'm going to take the Mississippi this direction. I'm going to pretend it goes that way. Am I right?
And it's that short?
You got fine science. All right. This could be the Mississippi.
That is really close to the traditional definition of the Mississippi River. But we could have just as easily called this the Mississippi. Why didn't we take it all the way over here?
Well, I think that would be the Missouri River, but why was the names given? I mean, they kind of named the river after some states that it's going to go through. But that's a good question, and I'm surprised I didn't know the answer to this any better.
So when we think about rivers, I like to think of watersheds because any river you have, there are going to be branches coming into it, and those branches are going to come from an area of land we call a watershed. Anytime you have an area of land where water is going to drain down into a river, a lake, or even a dry lake bed that only appears now and then, that's a watershed.
Do we live in a watershed?
Everyone lives in a watershed.
Oh.
So we don't have a river close by. Our watershed actually drains to a dry lake bed because we live in the desert. But when it rains, what happens to the dry lake bed?
Oh, it fills up with water.
It fills up with water. And anywhere in the watershed, what happens there is going to affect the river or lake or ocean because it's all part of the same system. So looking at the Mississippi River, if we're thinking about this part right here, the river delta, and what's happening down in New Orleans, Louisiana, well, things that happen up here can have an effect down there. And things that happen way up here in Montana can also have an effect on the river down there because all that water system is connected.
And the cool thing is, so each of these little tributaries then actually has a name, and it's known, and they're probably pretty good size, many of them.
Many of them are. Many of these river systems are. And there is a little challenge in the notes, and we will show you the answer at the end to see if you can map the Red River, Ohio, Mississippi, and upper and lower Missouri and Arkansas river basins. Because those are all pretty important for those areas.
Whoa. So if you tried to talk about how long the Mississippi River is, which branch would you even look at?
Now, the question of how long a river is actually fairly complicated. And for decades, people agreed that the Nile was the longest river in the world. But recently, some geographers went and did a survey in the Amazon, and now it's probably more accurate to call the Amazon the longest river in the world.
Oh.
But it all depends on which tributary you choose, and it can be a matter of debate. Now let's go to our the slides I made, Math Dad, and we have a couple fact or fictions to help us learn more about rivers.
Oh, I'm so ready for this.
At Two Ocean Pass, a river splits in half. One branch travels to the Atlantic Ocean and the other to the Pacific Ocean. Is this true or false? Could you have a fork in a river? You know, a fork in the road branches. Can a river branch?
But in a river, it's just going to go downhill every time. And so could there be two versions of downhill, and one of them would head to the Pacific versus the Atlantic? Oh my goodness. I mean, with a name like Two Ocean Pass, it kind of sounds like it's a plausible thing, but maybe you made this up.
Solar Eclipse says true. Eleanor says true. Coasty Coder says true.
I'm going to go with the chat on this one, but I have a hard time imagining where this would be.
And it's a good thing you trusted the Unbeatable Science Kids because they are correct. This is a real location in Montana in Wyoming. And the river, it kind of enters a marshy area where it's a little more even in terms of the elevation. So it's flowing downhill here. And then you can see that there's kind of this wetland area here, but it does. And this person is standing right by a sign that says this way goes to the Atlantic, this way goes to the Pacific. And then you have Atlantic Creek and Pacific Creek.
Okay, that would be a fun place to visit. I'll just spill some water here. Oh, goodbye, water. You're off to the Atlantic. And then, whoop, bye, water. You're off to the Pacific.
Exactly. So rivers can fork. It's more often that they come together and join, but they can split. Another fact or fiction for you, Math Dad. Most years, the Colorado River does not reach the ocean.
Okay, the Colorado River is a big, important river. Maybe it doesn't have the most water of all rivers, but we wouldn't reach the ocean. How would it not?
So you have a big river. This river goes through the Grand Canyon. People water raft on it, and it's really large. And then it just dries up and ends up in sand and desert.
It can't just dry up. There's too much water. This is fiction.
We're seeing mixed results from the chat, but you should have trusted Amy Peterson and Mary Catherine Fisher because this is true.
What?
This is true. So the Colorado River is a river that goes through deep canyons. This right here is Horseshoe Bend in Arizona, a very famous scenic spot where the river does a huge curve, but we don't know if this is ever going to become an oxbow lake because this rock is really hard. So I don't know if it's going to meet.
That's beautiful.
But as it comes down, it goes through the Grand Canyon, it passes through Lake Mead, it goes right by our house. So much water is taken out for irrigation in California and in Mexico that it actually does dry up before it hits the ocean.
Oh, wow.
But and I say dry up, what I should really say is it's all diverted to farmland before it hits the ocean. Only a couple times, and there was a big push where people agreed from all the states to release more water, to do a study to let water reach the ocean. Water reached the ocean a few years ago, and that was the first time in decades. Now,
that is kind of crazy because I mean, I know there's a water shortage and a drought, but I just assumed that a river would keep going, a river the size of the Colorado, but we use up all that water.
We use up all the water. Now we're going to look at 4 rivers today in this class. There are so many fascinating rivers we could look at across the world, but I wanted to limit it just to a few. And the Colorado I picked because the Colorado goes through mostly desert. And when the states first divided up the water rights, they actually divided up more water than the river usually holds.
So what water rights are promises of
how much water you can take out.
Okay.
Now let's take a look, because this is one of our clues in our Where in the World mystery on page 98.
Okay.
So this is the Colorado River, famous for whitewater rafting, travels through 15 dams and a giant deep canyon. That giant canyon is the Grand Canyon. And then after flowing more than 2,000 kilometers, it usually doesn't reach the ocean. It just reaches a lot of fields and irrigates crops. But take a look at this river. This is a picture of whitewater rafting in the Grand Canyon. What color is this water? What color would you say that water is?
That is a dirty brown. It looks really muddy, right?
It is
like
very
almost
muddy.
chocolate milk muddy.
And that's why it's named the Colorado. Colorado means color red in Spanish.
Colorado.
Colorado River.
I get it. That's cool.
And it is this color because it has a very high sediment load. It's carrying a lot of clay and silt. And when that river meets the Lake Mead near our house, take a look at this color. So here's the Colorado River, nice brown because it's all silty. And then here's Lake Mead, this pretty green color. Why do we have that change in color?
Okay. It has to be that the sediment is just sinking into the lake?
It is. All that sediment is dropping into the lake. And there's something else that is dropping. Take a look at this picture real closely. Notice this hill right here that kind of has a crescent shape.
Mm-hmm.
Notice this little inlet here and this little kind of diagonal inlet here. And then these right here.
Yeah, I see those.
Now I'm going to switch to the next picture. This was in 2013. This is just a few years later. Here's the Colorado River coming. And remember, this little inlet, this was all lake before, and so were these. And so was this little one here.
So the lake itself doesn't even start as early. The river has to come further to even reach the lake.
The river comes further. The lake is dropping.
Uh-oh. So as the water level drops, that means there's less available water. And is that due to drought conditions?
That is. There's a pretty bad drought happening right now around the Colorado River. So we already saw this picture with our river rafting, and now it's time for our next fact or fiction. You ready for this, Math Dad?
Bring it on.
Fact or fiction, there is not a single bridge over the Amazon River.
Well, it depends on what you call the Amazon River, Science Mom, because I bet up high for sure there, where before it gets too thick, too wide, there would be a bridge. But okay, so the Amazon River, it's huge, it's like as wide as a lake. But by the end,
at the mouth, it's really, really wide.
But you're saying there isn't a bridge over the river?
Not a single bridge over the river.
How could that even be true? Do you have to boat across it all the time?
Millie says fiction. Amy Peterson says fact. Great White says fact.
Amy was right last time, right?
Yep. Malcolm Burns says fact.
Fine, Amy, I'm going with you. Is it fact?
It is.
What?
So this is kind of remarkable, and it's not because we couldn't build a bridge over the Amazon. Engineers definitely could, but the Amazon, most of it goes through such remote areas that there isn't a need to build a bridge over it because you can take a ferry across, and there just aren't that many cities on the Amazon. One city on the Amazon, Manaus, there is a bridge over the Rio Negro, but not on the Amazon. So here's the Rio Negro, and here's the Amazon meeting. And again, just like with the Colorado River, why is this one brown? Is this a river of chocolate milk, Math Dad?
Well, that's the river. I thought that was land.
No, this is the river. This is the Amazon branch, and this is the Rio Negro branch.
So it has a high sediment load. So lots of clay and silt and sand inside that river.
Yeah, it's carrying a lot of sediment, a lot of clay, and a lot of sand.
Well, those are very different amounts of sediment. Why would one river have a lot of sediment, but the other would not?
It all depends on the rocks that the river is traveling through. So if the river is traveling through sandy sandstone and rock that is a little bit easier to erode, it's going to pull out pieces of clay and develop a really high sediment load, and it will be a brown river like the Colorado River. But if the river is going through an area where maybe it's igneous rock like granite or basalt, rock that does not erode very easily, then the water will be clearer because it's not going to be picking up as much clay or sand. So the Rio Negro means black river, and it is a river with not very much sediment. And then the Amazon, which those headwaters are coming from a different region, it's carrying more sediment. And when they meet, you can really see that difference before they mix together.
Yeah, really, really cool. I mean, such a clear dividing line.
Yeah. Huh. So there is a bridge on the Rio Negro right here, really close to the Amazon, But if you take the traditional way that we define Amazon, there is not a single bridge. And again, right up here, so here is the Rio Negro, and here is the Amazon. It all depends on how you define the river, right?
Right.
If we had called this the Amazon instead, it would be shorter, and then there would be a bridge on it. But when we call this the Amazon, there is actually no bridge, mostly because it's so remote. Now, this river, not only is it, most people will say it's the longest now after that recent survey, although sometimes when you look up the Nile, it will say the Nile is the longest. They're kind of in a race for which one is the longest, but we think the Amazon has won.
Do the lengths of the river change over time?
No, but it depends on which tributary you pick. So which tributary are you going to pick? And then when you get all the way up here in the top of the Andes, that's difficult terrain to do a survey in. But the Amazon is by far the largest river when it comes to how much water is coming out.
So the total volume of water.
Yes. Now, this is also a tricky thing to measure because in the springtime, when there are more rains, there is going to be more water coming out. And if there's a drought and there's less rain, then less water comes out. So how do you figure how much river a water has going down it?
How much water a river has? An average across the year, maybe?
Yeah, they do an annual average. And if we look at page 95 in the notes, we made a little graph where we showed you circles that represent how much water comes out. And first, I just want to point out the Mississippi River. This is a huge river. If you've ever been down to New Orleans or seen in any part of Mississippi or seen the river, it's enormous.
Yeah, I never would have imagined that a river could be a mile across.
So it has an average discharge of 16,000 meters per second, but the Amazon has a discharge of 209,000 meters per second. That's more, so think of a bathtub. That's more than 1 million bathtubs being poured out of the river every second. That's how much water is coming out.
That's a lot of water.
And if we compare these rivers, the Amazon, the Congo, which is in Africa, the Yangtze in China, look how small the Nile is comparatively.
Wow. So I would expect the Nile to be a big river. However, it does go through a lot of warm part of Africa. So it's not as big?
Well, it's very long, but if you look at pictures of the Nile at the headwaters versus the Amazon at where the river's coming out, you know, the Amazon, if I plunked you in the middle of the Amazon, just a mile from where it reaches the ocean, you'd think you were in a lake. I mean, it's like horizon to horizon river. Whereas if I put you in the Nile a mile before you reach the ocean, you'll be able to see both of the banks really easily. It's not nearly as wide, but it is very long.
Right. So the Amazon River is fed by the rainforest, right? That the Nile River doesn't have quite that much of a source.
The Nile River is fed by rainforests as well, but they are all the way in Ethiopia and Rwanda. They're far away from Egypt.
Gotcha.
But that's where it gets its water as well. All right, back to our slides. We have a couple more fact or fiction.
Oh, okay.
So this is the Nile River Delta, and then a map of the Nile just to show you where we're coming from. So here's Ethiopia, and then all the way down in Uganda, and even reaching up to Rwanda.
Kenya.
Yeah, that is a long river system. But as it comes out, it forms a beautiful fan-shaped delta where all of that sediment and those little pieces of clay it was carrying, they get dropped and it makes new land.
So was this whole delta at one point underwater? Or rather that sediment that got dumped here?
That's all made from silt from
all
the river.
I mean, you can really see this. That's a really cool shot. There's no mystery as to where the Nile is flowing in this picture.
Yeah. Now, here, just for fun, Math Dad, I want to see if you can explain this. Okay. So we're talking about rivers and about water, and sometimes when I turn on the tap and the water comes out of our sink, it will look almost white for just a second, and then if I wait a few minutes, I see that it's small little bubbles, and eventually the water turns just a regular clear color. What causes this?
With the small little bubbles, there are lots of them, and then they start turning clear as they disappear.
Yes, but where did the bubbles come from?
Oh, I thought I got it right.
And let us know in the chat if you've ever seen this before.
Right, so where do those bubbles come from? Well, a lot of the faucets will have an aerator on them, and so they're actually trying to slow the water down. Is that?
That's a good theory, but that's not where they come from.
What?
Because it's only every now and then. Usually when I turn on the faucet, the water looks like this, almost always. But once, maybe every 2 or 3 months, it looks like that.
So some air bubbles got in the line further down? Is that it?
KNH says pressure, and Noah says pressure, and pressure is correct.
What?
So this is a bottle of soda, and I took off the label, and what color is it?
Very clear.
Completely clear. But is there air in here?
Up at the top, I see air.
Up in the top, there's air, and it's under pressure. There is dissolved gas in here, mostly carbon dioxide. And if I release that pressure...
Can she do it?
Trying to do it slow because I don't want to make a mess.
I see bubbles.
You saw some bubbles come up. So if we have high pressure in the pipes and the pressure gets high enough, and maybe if there was a little bit of air that was in there, the air can actually get pushed into the water, just like you can get carbon dioxide pushed into soda. And then when you let it out, all those bubbles come out.
Okay.
So that's a mystery solved.
That was pretty cool.
All right. And next, I have a where in the world mystery for you.
I'm ready. Bring it on.
Asia's longest river is fed by 700 tributaries, and its drainage basin covers 20% of China's total landmass.
Oh, wow. So the drainage basin, the watershed.
Yes, the watershed is enormous.
20% of China's landmass. Well, I've got to go with the Yangtze.
Yes,
Yeah.
That is correct. So the Colorado we talked about earlier, and the Yangtze is the largest river in China by a lot. It's one of the hugest rivers on the planet. And it also has some incredible animals that live nowhere else, including the Yangtze river dolphin, a type of sturgeon. Here's a map showing you just how big it is. I mean, it starts here, comes out by Shanghai, but it goes all the way up into the Tibetan Plateau, an enormous river.
I noticed a lot of cities seem to fall around rivers.
A lot of cities do fall around rivers. That's because it's important for a city to have a water source. And one of my favorite animals is the Chinese giant salamander. This salamander is the largest amphibian in the world. Guess how long, Math Dad?
3 feet.
Taller than you.
What?
They can get up to 5.5 feet in length, or even closer to 6 feet in length.
Oh man, I'm 5.5 feet tall.
The biggest Chinese giant salamander was even longer than you and me.
Oh man, I got beat by an amphibian.
All right. We hope you enjoyed learning a little bit more about rivers and some of the biggest rivers in our planet. And now we have some quiz questions for you, some fact or fiction, to see if you can show us what you learned.
All right. So we're going to head over to itempool.com/sciencemom/live and try some questions. So to start with, got a true false question.
Well, actually, to start with real fast, we have a happy birthday to wish to Shyla in Alaska, who turns 10 tomorrow. Happy birthday, Shyla.
Go Shyla. All right. The true or false? The 10 largest cities in the world are situated on the banks of rivers. So here's Las Vegas, the big city that's by us, certainly is not by the bank of a river.
Nope. The Colorado River's not too far, but yeah, people didn't settle there for a river. They settled there for the aquifer and the spring that was in the middle of the valley. But the 10 largest cities in the world, are all of them by the banks of rivers?
Mm-hmm.
Let's go ahead and finish and reveal.
All right. And
the answer is true.
Ooh, they got it right. So it is true. You just need a lot of water when you have a lot of people. And
historically, people live where there's water. So people have often lived by rivers.
Absolutely. All right. Up next. So a river begins at a blank, follows a path called a blank, and ends at a blank. All right. So we've got course, mouth, source. So those are the 3 words that are going to go in the blanks. So where does the river start? What do we call the path of the river? And where does the river end? Oh, Calvin's eating treats off my shoulder.
He's been taking a good nap, but now he has woken up. And Solar Eclipse wants to know why do rivers tend to look a little gross when the water flow isn't strong enough? A river can look so different depending on how much water is flowing through. The water doesn't just provide life to plants and animals. It also helps to clear out sediment. So when the water flow is low, the water can't pick up things as big, and you'll end up with more silt.
I think you'll get a lot of pond scum and things if the water isn't moving very fast.
Yep.
All right. And the correct answer was C. So the river begins at a source. It follows a path called a course, and it ends at a mouth. And source and course sound a lot alike. I kept messing up the spelling. They both have an S and a C, but you just swap them. All right. Nicely done on that one. Ooh, the largest river in the world by discharge is so what's the name of this river? You guys have to type it in. I'm not even giving you a hint. Not a multiple choice question. Can you do it?
And I think we should have just said largest river in the world, because no matter how you try and define large, this one is the largest.
Okay. Judging by the bars here, I'm guessing I'm not going to stump them on this one. All right. This is good. This is kind of fun. This might test their spelling, if nothing else.
It might. If you can get me back to our slides, Noah asked if we can tell about the big fish picture. So as soon as we finish this one, as soon as we reveal the answer, we'll pull that up real quick.
All right, I'm going to call an end to this one. And the answer is the Amazon.
Amazon, nicely done.
In second place, we have Marmoset. And in third place, Amazon River was also a great answer. Good enough.
And fourth place, Nile. The Nile is actually, according to that newer survey, it's more accurate, we think, to call the Amazon the longest. But let's look at the Amazon real quick again, because if you have a big river, you tend to also have big fish. This is an Aripama, one of the largest freshwater fish in the world. This is a painting from, I think it was back in like 1857. The date on this painting is really old, or on this drawing that someone did of someone fishing, and just to show the size of the fish that live in the Amazon. And although I've seen pictures of ones just about that big, modern pictures. So you have big fish in the Amazon.
That is crazy big. I mean, I'd be more worried about the piranhas, but that's still a little intimidating to think of fish that size swimming around.
Yeah.
All right. Question number 4. When a river curves, the water moves fastest and most erosion occurs on the outside or the inside of the river bend. Which is it? Where is the water moving the fastest, on the outside or the inside?
And then Yana has a really interesting hypothetical question. What would happen if for a little while all the water on the world went away? So let's say just like 5 minutes, just, magically all the water disappeared and then it would come back. So 2 things would happen. 1, and all the aquatic animals would die, which would be very tragic. But 2, our planet would get a lot warmer all of a sudden, because the white water of the ice in the poles reflects heat. The white color of the clouds reflects a lot of heat. And then when sunlight comes in and hits the oceans, water takes a lot of heat before it changes temperature. So the oceans absorb a lot of heat from the sun. And I would have to do some research and to try and calculate just how much the temperature of the planet would increase if all of a sudden all the water was gone. But I think the side facing the sun, I think it would be a huge increase in temperature. It would not be pleasant for anybody.
That's a really interesting question. And it hadn't occurred to me. I guess you'd lose the clouds too.
Yeah, so the one-word answer is catastrophe. That's what would happen.
All right, just 5 minutes. The answer is the outside. Oh, man, they got it right again.
They did.
Okay, not bad. And then, final question. What is a watershed? Is it a small building for storing water, an area of land that drains to a waterway, such as a stream, lake, or ocean? Is it a tributary of a river, or is it a river delta? What is a watershed? This might be the one, Science Mom.
I don't know. I don't think you're going to stump him at all, Math Dad.
Oh, look at that bar grow. Clearly, they're all following a false trail.
Nope. we did have one question come in the chat about why we call a watershed, and I'm not entirely sure.
I think like a dog sheds its fur, it's the hair shedding hair, and the land is shedding water into it.
I guess. I guess.
Know. But yeah, okay, the answer is indeed B. They got it right. It's the area of land that's draining towards a waterway.
Nicely done, you guys. I do want to show real quick the answer to the activity on page 95. So hopefully you will give this a try yourself. But if you haven't yet, let's talk real fast about the drainage basins for the Mississippi River. So here is this delta, and the river goes all the way out to the end here. And that's because this land was created by the river. The river dropping sediment. And the Red River drainage is here. All of those tributaries are connected. All of these tributaries, the Missouri, they connect and lead to this point right here where they drain in. And then the Ohio River is here. It's kind of a neat way to look at that watershed, isn't it? To see all those pieces.
Yeah, it is.
And then I am seeing that...
Like a diagram of blood vessels almost.
Yeah, it kind of is. I'm seeing several requests for the Russian squat dance. So that is the victory dance that we will show.
Oh man, I get sore just watching that one.
It is not easy to squat that low.
All right, guys. On Friday of this week, our next class, it's time for a quiz show review. And I think I'm going to crush him, Science Mom. The egos are starting to grow too much. I've gone easy on them for too long, and it's time to put the kibosh on that.
We have had easier questions, and we are coming up with some pretty advanced, more challenging ones. So you can get ready by taking the practice quiz that is pages 96 to 97. Take that to warm up, and then come on Friday so that the unbeatable science kids can continue their streak.
I don't know if they even dare show up. They might not even watch it. It's possible no one will even tune in on our next class.
So
I don't blame you guys.
You guys need to come to put the kibosh on this ego. That's what needs to happen. I hope that you guys have a great day. Work hard, grow smart, and we will see you on Friday.